All right, so here we are again for the next week. Y'all kind of bear with me. I am kind of under the weather today, so hopefully I can get through this. All right, so let's begin. As you already know, I'm DeMia Hendrix. For today, we're going to go for Chapter 8. Chapter 8 is over algebraic reasoning, and it deals with graphing, and it deals with connection with geometry. So today, throughout this video, I'll be telling you about each of the three, and even work some problems with you. So when I think of algebra, so for me, when I think of algebra, I always think of like X, Y, and Z. It's always automatic. I'm thinking about how to solve for Y, thinking in for X, maybe even Z. Um, but you have to realize that algebra is way more than this. You need to understand that it has patterns, it has different relations and different functions. Patterns can be as simple as 1, 3, 5, and 7, and as complex as 1,088, 1,176, 1,264. Patterns are just the generalization of algebra relations. Um, so, what is algebraic reasoning? Algebraic reasoning is used to solve problems and understand patterns by following certain steps. These steps include introducing variables, derive algebraic expressions, form equations, solve those equations, and interpret the solution of the equation. Um, so, for an example, another thing that you do in algebra is graphing. So, for these next two slides, I have different type of graphs. For an example, this is what you would call a bar graph. So, I just kind of created this one, and it's just going back to different things. So, usually when you look at the side tells you how far up, and if you look long ways, it's telling you different categories. So, for an example, this can be Susie's category, and she has however many cookies on whatever day. This can be Jane, this can be Julie, and so on and so on. And then with the bar graph, this is another bar graph. This one is based off favorite colors. So as you see over here on the left side, I have the orange, blue, green, and pink. And then long ways for the columns, I have the numbers. So for this one, you see that blue is the favorite color out of the students for today. And then you have something that's a little more complicated. They're known as line graphs. As you see, you still have the title, Cake Sold. On the side, you see the numbers. On the bottom, this time around, you have the days, and then you have your key, and it's showing you each color is based off who. So you have Jane, you have Kathy, and you have Daniel. And then you see on the certain days, for an example, with Daniel, it seems as if Tuesday was his lowest day, and Monday being his highest on selling cakes. And then we have a few definitions. We're going to start with Pythagorean theorem. So for you that don't know, Pythagorean theorem is the square of the hypotenuse of a right triangle, which is equal to the sum of the squares of the other two sides. And then we're going to talk about the distance of the opposite side of an angle of the triangle, which is the hypotenuse, the distance formula. You definitely need to know what it means when it says greater than, so a number is larger than another number. Number line, you need to always be able to read a number line. The number line is a picture of a graduated straight line that serves as an abstraction for real numbers. And then coordinate planes are formed with X and Y axis on the number line. And then next we just have some more definitions. I decided to do an example column at the bottom, kind of going to triangles and the delta triangle ratio, slope, different things like that. Just definitions dealing with the linear and nonlinear functions. And then you also have the angle relationship definition, and it's just going over different type of angles. And then I have an example at the bottom. And then we kind of get into our homework problems. So for an example, for number one, we're dealing with graphs. So of course, back towards the beginning, I have different definitions. So with problem one, like I said, we're dealing with graphs. When I started this, I did have a few questions. So basically, I kind of used what I was wondering to use my questions for this problem. My first question was, why does each problem change the way the graph looks? So if you're like me, I kind of have issues with reading graphs. I just feel like it's a lot of lines and it scares me. So I had to tell myself each time looking at a different graph, you'll always get a different picture because you have a different scenario each time. And for these problems, like we have one for an example that is using the flagpole, it's different because you have to incorporate the sun and the shadow, and then we had one that was dealing with the ball, so you have to think about how the gravity is pulling the ball down. Something that I was curious about was, well, that I noticed was on the problem about the elevator. When it's going up, it takes these pauses and then it continues to go up. And I was like, why would it pause and then go up? And then I thought, oh, okay, because when you're on the elevator, you go to a certain floor, it's stopping, and then it proceeds from that point and continues to go up. And then another question I had was, why does the graph get smaller with the ball bouncing? And I kind of had to think on this one, but what I had to do with this one, I'm a more visual learner. So when I got a ball and I was bouncing, and of course it showed each time that the ball hit the ground, it would start at a lower point, like it was showing on the graph. So gravity had a point in that. And then my fourth question is, why does the flagpole graph make the U shape? So that was one of the first things I noticed when I was doing the graph with the flagpole. I noticed that it made the U shape, and so I was like, "That's kind of cool that you're talking about a flagpole. Why is it making this U shape?" And it's the sun and shadow played a part on that. And then I said, "What would make the graph different if the elevator was going down?" And it would just be the complete opposite of what it already looked like. So let's look at some of the answers I came up with for problem one. Right here at the left, at the top, is my graph for the amount of gas in a gas tank when a driver refuels the tank on a drive across the country. So as you see, like it gradually goes up, and then all of a sudden it just kind of stays even as it goes on. And then the one in the middle at the top is the height of an elevator stopping on each floor. So as you see, it's kind of going like staircases kind of, and it's stopping at each floor as it goes. And then you have the height of a bouncing ball. So like you see at the beginning, when you drop the ball, it goes very far, but then when it hits the ground, it goes up, but it doesn't go as far down when it's coming back down. And each time it's not as far down as the first time. And then the one at the bottom is talking about the flagpole, the U shape, throughout a sunny day. And as you see, it is definitely the U shape that I was talking about. And then you have the homework problem 2, and this one is about functions. I wouldn't say functions are my favorite, but I am very grateful for Excel. So I was very excited when you added the little footnote saying that Excel would be a good thing to use for this problem. Some of the questions that I came up with before doing my problem is, why is this problem more easily done in Excel? And it's because Excel easily calculates the function. So even though this one was kind of simple, you will have more problems in the future where they're more complex, so you don't want to have to do everything by hand or by calculator. You can just go into Excel and type in a certain formula or look up a certain formula and it will do it for you. In what order, my second question is, in what order should g of x equal g of f of x be solved? And I said you first should calculate f of x and then calculate g of the f of x. And then my third question is, what is the difference between g of x equals g of f of x and f of x equals f of g of x? It's kind of a tongue twister. And I said that for f of x, you will calculate it in the reverse order of g of x. And then what are the 3 headings a person should use in Excel? Well, I love Excel. It is a little complicated, so I felt like using Excel, I should kind of give a little background on what to do with Excel, because you may have students who have never used or just don't really understand Excel. And for a while, I was that kind of student. Like, I would love Excel, be able to use it. I would love to be able to use it, but some things are just more complicated. So one of my questions was focused on the headings. So I said that basically when you're doing your headings, you're kind of just using what you already know to do your formulas. And then for my 5th question was, what formula should you use under each of the headings when solving this problem in Excel? And then I just kind of said what I did. So under the x, I just inserted 0 through 3. And then under f of x, I just used equals 3 star, and then I clicked on the number under the x column and then the number under the g of x column. And then I used equals 8 plus, and then used the same numbers from f of x. And I just put the formula in and I just dragged it down. As you can see here, they kind of go more in depth. I started with my columns all the way across x and then f of x, g of x, and then I just numbered it 0 through 3. And then in my first box of my f of x column, I had inserted equals 3 star, and then I clicked on my first box and it did the formula for me, and then I dragged it out. So that's a little, so I got a little complicated in the first hit, the little visual kind of. And then we're on to homework problem number 3. And this one is talking about line segments and how the segment is vertical, horizontal, and slopes. So for my problem questions for number 3, I said, what is the slope formula? Because obviously if you're doing slope, you're going to need the formula. So the slope formula is y2 minus y1 all over, all divided by x2 minus x1. And then if you're doing the slope formula, you need to know what it tells you. I mean, you can do a formula all day, but if you're not understanding what you're getting with that formula, you're not going to really have much use for it. So I said that what slope does for you is it tells you how far apart each point is from the others and the rise of run form. Sorry. And my third question is, what direction does a positive slope go? And of course, it's upward, right? So how I remember is if I'm being positive, I'm going upwards, and if I'm being negative, I'm going downwards. So that's the answer to my next question is, what direction does a negative slope go? And you go downwards to the right. And then my final question for problem 3 is, what happens if the denominator of the slope formula is 0? Then you automatically know that the slope is vertical. And then these are just my answers from each question. I labeled everything, so you'll see which one goes with which. And then, sorry, excuse me, we have homework problem 4. And with this one, we're talking about graphs and functions and the differences between the graphs. So some of my questions for number 4, I asked, what form is the equation given in? And it's in the y-intercept form. What does y equals x squared look like? And I said that it gives you the letter U. So kind of back to one of our other questions with the flagpole, that U keeps coming up. What is similar about the graphs? What is different about the graphs? And then I also asked, what is a y-intercept? And it's where the function will cross the y-axis. And then just in case you're wondering why I didn't answer the difference and the similarities, is in my answers already. And then we're on to number 5. And in number 5, we're talking about equations of the line through the given point that is perpendicular to the given line. So my questions for problem 5 is, how do you get the slope of the perpendicular line? And my answer to that was that the line is the negative reciprocal of the original slope. So you have to know what the original slope is. And then my second question is, what is the perpendicular slope for an equation that is y minus 3/4 x plus 5? And I said it's 4/3 because you're just flipping it and you're changing it, so you don't need the negative anymore. And then I asked, what is the perpendicular slope for an equation that is y equals -9/2 x plus 5/2? And it's 2/9 because you're flipping it, which is a reciprocal, and then you're getting the negative. So since it's negative, it'll change to a positive. And then what form must you put the equation in and solve for the equation given? And you should put the point slope form in. And then my last question for question 5 is, for problem 5 is, what do you need to find the equation of a line through a point that is perpendicular to a given line? You will always need an equation of a line and a point. And then those are our answers to the homework problem. And then to our last problem, homework problem 6, this one is talking about like the origin and the tangent. And if you're anything like me, like you kind of have a hard time with these. Of course, I kind of know where everything is. And I feel like with teaching students, you have to have the background, like the beginning of the background knowledge to be able to do the whole point. So as you're going to see in the next slide, most of my questions are kind of just getting the background knowledge. So for an example, my first question is, what is a tangent? And I said that the tangent is a straight line that touches the curve but doesn't go past that point. Always remember the very ending and never goes past that point. What is the origin? The origin is the starting point. And then the radius is the straight line from the center of the circumference of a circle. And then I asked, well, I always have the given circle. You'll always need the given circle to be able to work the problem. And then how do I solve this particular problem? And then you're solving for y in this case. And then here are my answers for this. And that's my PowerPoint, guys. Thanks.